Hi class. This lecture here continues our lecture series talking about solving trigonometric equations. And this is going to be our lecture number 4 here in this series. And what this is this is solving using trig identities. And so there are so many trigonometric identities. I couldn't possibly do an example for every type of problem. So what I have here is I have 4 problems picked out, and it's just to help you kind of see the process. So about like identifying, hey, I need some type of trig identity here, and plugging it in and solving. Okay, so here'll be the first one. So in our lecture series, we're up to now example number 15. Feels like we've done so many more, but let's solve this. So let's solve 2 times cosine squared of x minus sine of x minus 1 is equal to 0. And let's just do this on 0 to 2 pi. All right, so here's the problem, right? I can't factor this because I have sines, cosines, so this isn't so easy. But look, do we have a Pythagorean identity for cosine squared to put it in terms of sine? Yeah, we do. So watch. Recall, and I highly encourage you, what you really should be having here is like a cheat sheet of all these trig identities. Okay, so you'll look down your cheat sheet and your trig identities, and you'll say, okay, is there any way I can get, what is cosine squared equal? Cosine squared of x in terms of sine. Okay, I want to see if I can replace cosine squared in terms of sine, because there's nothing for sine, okay, by itself. So if you do, you'll see that this is equal to 1 minus sine squared of x. So now watch what I'm going to do. I'm going to plug this in and see what happens. All right, well, let's follow through and see what happens. So 2 minus 2 sine squared x minus sine of x minus 1 is equal to 0. Well, 2 minus 1, so I get minus 2 sine squared of x minus sine of x plus 1 is equal to 0. Well, I have a leading negative, so I'm going to multiply both sides by negative 1, and you just end up with 2 sine squared x plus sine of x minus 1 is equal to 0. And look, this you're going to solve this. Now it looks quadratic in nature. So, you can follow the previous lecture, but hopefully you see that this is going to factor as 2 sine x minus 1 times sine x plus 1 is equal to 0. So then you're going to have, using the 0 multiplication property, 2 sine x minus 1 is equal to 0, or sine of x plus 1 is equal to 0. So you're going to solve, when does sine of x equal 1/2? Or you're going to look, when does sine of x equal negative 1? Well, let's just go through. Sine, when is sine 1/2? Pi over 6. 5 pi over 6. So solutions over here are pi over 6, 5 pi over 6. And then you're going to look, when does sine of x equal negative 1? Right here, 3 pi over 2. So your solutions, just from 0 to 2 pi are pi over 6, 5 pi over 6, and 3 pi over 2. We got it. All right, so, you want to get it in terms of one trig function if you can, all right? All right, let's take a look at one where maybe it's not gonna work out like that, and you're gonna get 2 trig functions, and how you'll handle that one. All right, so here's example 16. Let's solve sine of 2x, so we have a double angle here, is equal to sine of x. And let's look on 0 to 2 pi. All right, here's what you're going to do. You're going to recognize that this is a double angle. So you're going to use the double angle identity. Okay, and if you look, you can see that sine of 2x from previous lecture is equal to 2 times sine of x times cosine of x. All right, so let me plug that in now, okay? So sine of 2x gets replaced by 2 sine of x cosine of x is equal to sine of x. Now there's always this like propensity to be like, oh, let me just divide sines and they'll cancel out. But you don't want to do that, okay? What you want to do is you want to subtract the sine over, okay? Because if you do that, you're going to end up missing some of the possible solutions, okay? So you have 2 sine of x times cosine of x minus sine of x is equal to 0. And now look what you can do. You can factor out a sine of x. And then you have something times something equals 0. So either sine of x is equal to 0, or 2 cosine of x minus 1 is equal to 0. So just getting cosine by itself here, you're looking here where cosine of x is equal to 1/2. All right, but like let's start. When does sine of x equal 0? Well, that's here at 0 and pi. And then look, when does cosine of x equal 1/2? That would be pi over 3 and 5 pi over 3. So even just putting these in order, right, you get x can be equal to 0, pi over 3, pi, and then 5 pi over 3. All right. So, recognize this double angle. Let me put that right in. Okay, that identity. All right, let's do another one that involves maybe just recognize something here. Okay. All right, so let's move into example 17. Let's solve sine of x times cosine of x is equal to the square root of 3 over 4. Now look here. I know that 2 times sine of x times cosine of x, okay, is equal to sine of 2x. So let me multiply both sides by 2 here. So I have 2 sine of x times cosine of x is equal, when I multiply this by 2, I end up just getting the square root of 3 over 2, which is great because if you look at my unit circle, I see a bunch of square root of 3's over 2. So now this I can replace as sine, using the double angle, sine of 2x is equal to the square root of 3 over 2. Okay, and I'm sorry, and again, we want to solve this on 0 to 2 pi. All right, so you're going to look, okay? You have to be super careful with this, okay? Now watch how I do this. So I'm going to look, when does sine of x equal square root of 3 over 2? So that would be pi over 3. And where's the other one here? 2 pi over 3. Right? That's where sine is square root of 3 over 2. All right, so look, I'm going to start by setting this up as the general solution. So this is equal to pi over 3 plus 2n pi, or 2 pi n, it doesn't matter how you write it. Or you could have 2x is equal to 2 pi over 3 plus 2n pi. So you're going to divide everything by 2. And one solution is x is equal to pi over 6 plus n pi, or pi n, doesn't matter. Or x is equal to, when I divide by 2, the 2 cancels out here, so you get pi over 3 plus n pi. So because you want to be between 0 and 2 pi, you could have n is equal to 1. So when n is equal to 1 here, you're going to get pi over 6 and then 7 pi over 6. You're going to get pi over 3. And then you're going to get 4 pi over 3 when n is equal to 1. Okay. So, you know, just putting this in order. Get pi over 6, pi over 3, 7 pi over 6, and then 4 pi over 3. So a little bit harder, right? Like you needed to, needed to recognize, to multiply it by 2, and then, hey, I need to find the general solution, and then figure out, how many times, I can add this pi here and to get to be between 0 and 2 pi. All right, let's do one last one, okay? So now we're at example 18. All right, so let's solve cosine of 2x, so that's a double angle, plus cosine of x plus 1 is equal to 0. All right, and let's solve on 0 to 2 pi. So what you have to do is you have to look back at all the double angle identities, okay? And you have to figure out which one to use. And so there's one that looks like this. Cosine of 2x is equal to 2 cosine squared of x, all right, minus 1. Now let me substitute that in. Okay, so then I have 2 cosine squared x minus 1 plus cosine of x plus 1 is equal to 0. This is awesome. The ones are going to cancel out when you do this. So you're left with 2 cosine squared x plus cosine of x is equal to 0. All right. Well, check this out. Check this out. They each have a cosine. So let me factor out a cosine of x. And I'm left with 2 cosine of x plus 1 is equal to 0. Zero multiplication property. So you're looking, where does cosine of x equal to 0? Or here you have 2 cosine of x plus 1 is equal to 0. Here you're looking, where does cosine of x equal negative 1/2? Right, so start, when does cosine equal 0? Pi over 2, 3 pi over 2. And then when does cosine equal negative 1/2? Well, that would be here, 2 pi over 3, and then 4 pi over 3 here. So just putting these in order, right? And if it helps, to go, around the unit circle, it tells you what order to put them in. So pi over 2, 2 pi over 3, 4 pi over 3, and then 3 pi over 2. All right, class, as with all of this, the more you do and the more you practice, the easier this will become. And as always, I'm here if you have any questions, and you're going to get a chance to practice this in the coming weeks.